Welcome to Chapter 7, Dummy Variables, how to use dummy variables to get different slopes, and then a quick discussion of categorical variables. In a previous lecture, we discussed how to use dummy variables to get different intercepts for your regression model. In this presentation or lecture, we're going to talk about how to get different slopes. What if you think that the slopes are different between your categories? How are we going to accomplish this? We're going to do something that's called an interaction effect. An interaction effect means that we're going to multiply two variables together. We're going back to our we rate dogs example. What we want is to allow the number of comments to potentially differ between Goldens and non-Goldens. We've already been able to look at the intercepts differing between Goldens and non-Goldens. Now we want the slopes, or how the number of comments changes if your dog is a Golden versus if your dog is not a Golden, or whatever, the video, the We Rate Dog video that we collected these data on. Okay, so to create this interaction effect in Excel, all you do is you multiply two columns together. In this case, we want Golden times comments. Here, this is just this times this equals this. So basically you just do it once and then you do the arrow and double click and then it copies down for your entire data set. We can see that it's 0 for our first 4 observations because those are not Goldens, and 0 multiplied by anything is still 0. And then for our fifth, since it's a Golden, 1 times 937 equals 937. In this example, we still have likes as our dependent variable, and then we have Golden, comments, and then Golden times comments. If your dog is not a Golden, then every time it says Golden, it gets a 0. So this is 0 times beta 1. This is 0 times beta 3 times comment, but still it goes away. And so we have beta 1, or I'm sorry, beta not plus beta 2 times comment. There's that. And then if your dog is a Golden, then you put a 1 in for every time you see Golden. So this gets a 1 and this gets a 1. Therefore, your new model is likes equals beta naught plus beta 1. This is our new intercept. And then beta 2 comment plus beta 3 comment. Beta 2 plus beta 3, we can factor out comment. That's our new slope. We run this new regression. Our dependent variable is still likes. Our independent variables are Golden comments and Golden time comment. If we want to interpret this equation, if the dog is not a Golden, then you put a 0 every time you see Golden. So a 0 here and a 0 here. We get 31,542.27 plus 132.45 times comment. And then if the dog is a Golden, then Golden gets a 1. And the equation is 31,542 plus 35,330. This is our new intercept, 66,872. And then our new slope is 132.45 minus something very small, 0.23. Our new slope is 132.22. We can see that Golden is not statistically significant in the specification, and neither is our interaction effect, but we're just going to go with it. So sometimes it is and sometimes it isn't. In this case, it isn't. Okay, therefore the model changes as such. We're going to have both a different intercept and a different slope. The slope's not very different, but the intercept is still quite different. If it's not a Golden, this is our equation, and if it is a Golden, this is our equation. How do we interpret these variables? So the variable on Golden is relative to not being a Golden on average, holding the other variables constant. Goldens get 35,330 more likes than non-Goldens. And then how do we interpret Golden times comment? The slope, if the dog is a Golden, is negative 0.23 less than relative to not being a Golden. Here's the regression with other variables in. I didn't include all the interaction effects. I'm not a huge fan of interaction effects unless very specific cases. We'll see one in a different lecture, but in general, I don't love them, but sometimes you need to see whether or not, Like returns to education, we might want to see if it differs between males and females. To do that, we would use an interaction effect. So here I included basically all the independent variables that I collected when I collected these data. We can see that there's 64 observations. Our f-stat is the p-value for f equation, or our f-test is very, very small. So these variables, these 6 variables together, are jointly statistically significant. We can see that our R-squared is actually, for a cross-sectional data set as such as this one, it's pretty high at 86%. 86.42% of the variation in likes is explained by these 6 variables. And then if we look at each of these variables, GoFundMe, basically I noticed when I was collecting the data that if the We Rate Dogs dude asked for people to donate to the dog, that it got fewer likes, comments, etc. So I thought I'd create a variable. So GoFundMe equals 1 if it's GoFundMe, 0 otherwise. We've discussed golden ad nauseum. Here, if the We Rate Dogs post had a video associated with it, it got a 1, 0 otherwise. And then rating, again, remember this rating was weird. It said he was going to rate them from 1 to 10, but they actually go from like 11 to 15. The number of comments, and then the number of retweets. Let's see what's statistically significant. So GoFundMe is statistically significant. So what does this mean? That on average, holding these other variables constant, a post that has a GoFundMe link gets 32,453 fewer likes than one that does not have a GoFundMe, does not ask you to go donate to the dog. We can see golden is statistically significant at a 5% level. What does this mean? That on average, holding these other variables constant, if the dog is a golden, gets 26,221 more likes relative to not being a golden. Video is not statistically significant, so posting a video versus not posting a video does not impact the number of likes, at least when we include all these other variables. Rating is still not statistically significant, which again is not that surprising because it hardly varied, and it was pretty random, his ratings. Comments were, so on average, holding these other variables constant, if one additional comment yields 119.36 additional likes, and then retweet is not statistically significant. So this is how we would interpret this regression analysis, is you would see that it's overall statistically significant, has a pretty high R-squared, and then of our 6 variables, we only have 1, 2, 3 that are statistically significant. The others 3 are not. Let's look at categorical variables pretty quickly. So what do we mean? That we just mean that these variables have different categories, and usually like more than binary categories, like video, not video, golden, not golden, more than that. These are 2 examples from survey data that we collect. So every year we do the economic impact analysis of the Holiday Bowl, and these are I just actually snipped these from the surveys we use. So question 11 is the person's age, and we give them ranges, and they're supposed to fill it in. And then question number 15 is their education level. So if they graduated from high school, if they've had some college grad, and then if they're had some grad school. Let's look at the education categorical variable. We can see that there is a distinct order here in the sense that high school is less education than college, some college is less education than college grad less education than grad school. Okay, what can we do with this kind of categorical variable? Well, your best option is to turn these into dummy variables. So we have 4 different options, 1, 2, 3, 4. Therefore, we need 3 dummy variables. I put the lowest one as the omitted variable, and so all my estimates are relative to this omitted variable. We have some college equals 1 if they answered some college, and 0 if they're high school, college grad, and grad school. College grad equals 1 if they answered that they were college grad, 0 otherwise. And then grad college, which means graduate school, if they answered grad college and 0 otherwise. And all estimates are relative to high school. And so some colleges relative to high school, college grad relative to high school, grad college relative to high school. This is your best option for categorical variables, is putting in one fewer, the number of dummies minus number of categories minus one for the dummies, and analyzing it this way. Your other option is to just include one variable, let's call it education level, and say that high school equals 0, some college equals 1, college grad equals 2, and then grad college equals 3. So this would be our new variable. The problem with this specification is that it's very, very specific in the sense that it puts a constraint on this relationship that probably doesn't exist. What do I mean by this? Well, this constraint says that going from a high school graduate to some college is going to have the exact same returns as going from college grad to going to grad school, because this slope is the same for all of these different changes. Therefore, this is not typically the specification that you want to use. The only reason that you should use this type of specification is if you don't have enough degrees of freedom to do a different kind of specification. So this is like a last-ditch effort because, again, we don't think that going from, let's say, some college to college grads is going to have the same returns as college grad to grad college. We just, I mean, you can look at data and see that this is not the case. So we're constraining with this specification for this to be there when it actually probably doesn't exist. Okay, I guess a third option is to put a numerical value on these data. So potentially you might want to pick the middle range and put that in the column called, say, age. For example, 18 to 24 entered as 21, 25 through 34 is entered into as 29.5. I think this is the worst of the options because you're basically just making up data. Like, for example, in the 18 to 24 range, what if most of your data or all of it is all 24-year-olds, but you're saying that they're 21? Well, I mean, if you're going to do that, let's just make up all our data. I mean, I really don't believe that this is your best case scenario, but it is an option. So anyway, those are your options.